Hello and welcome to Casual Learning. I'm your host, John Bannon. Today we're going to do a continuation of a review of my newest book, God and Our Superdeterministic Universe, the number one argument for the existence of God, which is available on Amazon Kindle. Um, we're at part two of my review of the second chapter of my book. Now, this is the most important thing you need to know if you're going to argue the existence of God. So pay attention. In June of 2020, a Swedish theoretical physicist named Dr. Johan Hansen published a proof in a peer-reviewed physics journal called Physics Essays at volume 33, number 2. It's entitled Bell's Theorem and Its Tests, Proof that Nature is Superdeterministic, Not Random. It's found at page 216 in volume 33, number 2 of Physics Essays. It's a very short proof. It's only 3 pages. There you go. It's the whole thing. But it's incredibly important. Now, I'll explain to you what the proof is and why it's so important. Okay, Dr. Hansen's proof is so incredibly important for 2 reasons. It tells us 2 things about the universe that we did not know. The first thing it tells us is that the universe is actually a predetermined Einsteinian block reality. Now, because Dr. Hansen's proof is performed at the quantum level, it's telling us that this is true even at the quantum level. So, quantum mechanics is actually the study of a predetermined block reality. The second thing his proof tells us, which is astonishing but true, is that temporal causation or continuous causation in physics is not real. It's an illusion of the brain. In other words, things do not actually get caused in time. So there is no invisible, metaphysical, causative force of nature that is constantly churning and changing or unfolding our universe anew at every moment in time. So it's not the situation that my existence a second ago has been changed to my existence at the present moment, which will be changed to my existence in the future. It's the truth is there is no causation going on. There actually is a me from a second ago that's still there in this block reality, and there's a me right now, and there's going to be a me a second from now in the future that actually already exists in that block reality. So there is no change or causation in time going on to maintain a single object like myself. It's actually a series of hyperplanes of space-time in a block reality, much like a flip book, for instance. And we simply experience reality as a geodesic traveling through that manifold of hyperplanes of space-time, like a figure drawn in a flip book. So as an analogy, flip book, you go through the pages, and if you draw a figure on the edge and you change its appearance with each page, it looks like it's moving, but it's really not. It's really a static reality in a stack. In this case, a stack of hyperplanes of space-time. So uh, that's astonishing that temporal causation is not real. Now, that's not to say that non-temporal causation is not real. That's a different topic entirely. But temporal causation is not real. It's not a real thing. And this has very important implications on the proof for the existence of God. Uh, because temporal causation is not real, continuous causation in physics is not real, then the wave function or some sort of metaphysical, mathematical quantum substratum cannot be real because it can't cause anything in time to make us believe it is real. There's nothing it causes. So why would you believe it was real? Well, that means that the universe is not the product of a random wave function. Rather, it's predetermined. And the question of who predetermined it ends with the answer God. So Dr. Hansen's proof is absolutely a linchpin to modern proofs of the existence of God. Very important to understand his proof and why it's true that temporal causation is not real. Okay, so let's get to his proof. To understand his proof, you have to understand what quantum entanglement is. Because his proof is a theoretical proof, and it's based on common knowledge of the typical quantum entanglement measurement experiment. Now, quantum entanglement is a situation where you have two or more particles that have been entangled through a special process, which basically means the measurement of one of the particles is going to depend on the state or measurement of the other particle. They're entangled in that sense. So the typical example of this is if you entangle two photons or particles of light. What happens is you can entangle the photons and then separate them any amount of distance in time or space. And when you measure the spin of one of the photons, the spin of the other photon, when it is measured, will always be exactly the opposite of the spin of the first one measured. So if the first spin is clockwise, this one will be counterclockwise. And the mystery of quantum entanglement, or this spooky action at a distance, is, well, how does this photon know what its spin should be in order to correlate to be the exact opposite of whatever the spin of this particle should be? Is there some sort of communication that's going on between these particles so that each understands what its spin should be so that the correlation will be 100% the opposite? Well, it can't. There can't be any communication because you can set up an experiment where these particles are so far apart and you measure them, and there would never have been enough time for one to communicate to the other what its spin should be prior after its measurement, because the speed of light can only go so fast. But you can make the measurements almost, uh, soon with each other that no communication from a light source going back and forth could explain the phenomenon. So it's considered a non-local phenomenon. And the question is, well, how does that happen? Dr. Hansen proved how it happens. And the answer is these two particles are predetermined to have certain spins. So it's already been determined that whatever the measurement of this spin is going to be, it's going to be the exact opposite of the measurement of this spin. It's predetermined, it doesn't change. And so what that also means is that measuring one particle's spin does not actually cause the other particle to have a particular spin, which means there's no such thing as temporal causation. Rather, it's all predetermined. It's simply uncovering the appearance of a predetermined block reality, a static block reality that doesn't change or isn't caused uh, to be the way it is. It simply is the way it has been predetermined to be. That's it. That's the explanation. Very simple explanation. So, how does Dr. Hansen prove all this? Okay, so Dr. Hansen takes the typical quantum entanglement measurement experiment. So he sets up an experiment where you have a lab table and an observer or an experimenter. And on each end of the lab table is a device that measures the spin of a photon. We'll just label them photon A and photon B. Now, these are entangled photons. So the simple measurement is the experimenter observes the simultaneous measurement of photon A and photon B. And because they're entangled, he observes a complete 100% correlation of the spins being opposite, which is consistent with the typical quantum entanglement measurement experiment. But Dr. Hansen then asks, well, wait a minute. Under Einstein's special theory of relativity, specifically the relativity of simultaneity, what would observers in different frames of reference see in observing this simultaneous measurement of entangled photons experiment? So Dr. Hansen proposes three different frames of reference. The first frame of reference is the guy who set up the experiment and who sees the simultaneous measurement of the entangled photons. Then there's two other frames of reference, one coming in from the left and one coming in from the right. So those two different frames of reference are coming in opposite directions from each other, parallel to the table and close to the speed of light in order for there to be a noticeable relativistic effect. Now, the relativity of simultaneity tells us Einstein's special theory of relativity, which has been proven correct over and over and over again for almost a century, tells us that what happens in this situation is that due to the relativity of simultaneity, this observer going in this direction will see B measured before A. And this is due to the fact that the speed of light has to be the same for all observers in all relative frames of reference. Now, similarly, the observer coming in from the other direction near the speed of light is going to see A measured before B. So these two observers see a different sequence of events. This guy sees A and B measured simultaneously. This guy sees B measured before A. And this guy sees A measured before B. Now, because events in the universe are independent of frame of reference, then the results of the measurements have to be the same for all three observers. So they all have to see the same 100% correlation of opposite spins. So let's say the stationary observer sees A is clockwise and B sees counterclockwise. Well, these observers also have to see that exact same result, okay? Because events are independent of frame of reference. However, quantum mechanics, orthodox quantum mechanics, orthodox quantum mechanics tells us that there's such a thing as a collapse of the wave function. So what it says is that for this guy, when he sees B measured first, then quantum mechanics would tell us that when B is measured, the wave function collapses and then sets the directly opposite correlation for entangled photon A, even though photon A has not yet been measured. But importantly, quantum mechanics claims that this guy can't know what the measurement result of B will be. It's a 50-50 chance. It's either clockwise or counterclockwise, but it's purely random. So it's a 50-50 chance. And the same is true for the other observer. So this sets up a real conundrum for orthodox quantum mechanics. So if this guy sees photon B measured first, then there's a 50-50 chance that it's clockwise or counterclockwise. And this observer sees photon A measured first, and there's a 50-50 chance that it's clockwise or counterclockwise. Then, because of that, these two measurements, A and B, cannot possibly result in 100% opposite correlations. It wouldn't be possible. So because this guy will see this either clockwise or counterclockwise, and the other guy will see this either counterclockwise or clockwise, and it's a 50-50 chance, and they both can't be right. So it could be either, which means you can't have 100% correlations of opposite spins between these two observers under orthodox quantum mechanics. Say, for instance, this guy, he has a 50-50 chance that this is clockwise. If that's clockwise, then this has to be counterclockwise. But this guy over here, there's a 50% chance this is clockwise or counterclockwise, which is inconsistent with this having to have to be clockwise because he observed a counterclockwise B spin. So what this is telling you is that there is no collapse of the wave function actually causing the correlated spin. It's not happening. The only way that this conundrum can be solved is if you say that these two spins are predetermined. That's the only way they could be the same for both these observers. So if they're predetermined, then these two are going to see the same exact results. All right. Well, this is a very simple proof. It's a theoretical proof, meaning Dr. Hansen didn't actually perform this experiment with these two observers going to the speed of light. But nobody, no physicist, is going to contend that the relativity of simultaneity is incorrect and that this would not actually occur if you did the experiment. Because then they would have to claim that Einstein was wrong about the relativity of simultaneity. Einstein has never been wrong about his special theory of relativity. So this is a solid theoretical proof. There's no doubt about it. There's no need to actually do this proof in reality to prove it's true. You know from the relativity of simultaneity what the result would be because it's Einstein's special theory of relativity. Therefore, what does this mean? It means the universe has to be predetermined. It has to be a block reality because this guy sees this B measured before A, but this guy sees A measured before B. So for this guy, A, the measurement result already exists. But for this guy who's seen B, the measurement result of A does not yet exist. But it's got to be whatever this guy knows it already is, which means this future event for this guy of the measurement of A has to pre-exist. It already has to be there, which means you have to be dealing with a block reality. So it's just a matter of this guy waiting a little bit longer to find out what A already is predetermined to be. Uh, okay, so that's reality. The universe really does not contain continuous causation or temporal causation in time. And it really is a block reality. Now, you can argue about how um, how wide that block reality is. Does a block reality consist of the entire whole block universe, like Einstein would say? Or is it just a sliver of a block universe that's created, annihilated, and recreated within a certain amount of time through a philosophy like occasionalism? No one knows the answer to that. You can argue both, um, but but this proves it is a block reality, regardless of whether it's a whole universe or just a sliver constantly turning over in time, creating time, but turning over, being created, annihilated, and replaced with the next sliver of this block reality, consisting of a manifold of hyperplanes of space time. Uh, so, very important stuff. Get to learn it, get to understand, read the proof for yourself, understand what it's saying about reality, what it's saying about the quantum level. And, because temporal causation is not real at the quantum level, because this experiment involves quantum entanglement. So that's at the quantum level. If temporal causation does not exist at the quantum level, there's no reason to believe it exists at the macro level or larger scales like our physical reality because of reductionism. Why would it exist at our level and not exist at the quantum level? The quantum level is more fundamental. So if it doesn't exist at the fundamental level, temporal causation doesn't exist at the fundamental level, why would it exist in the macro level? It wouldn't. I hope to learn something. I'm going to continue my videos on chapter 2. It is a very long chapter, very complicated. And But this is really important. So try to memorize this. All right, take care, everybody.